Start with quiz to see here. First question is you want to find the volume of the paraboloid z equals 9 minus x squared minus y squared above the xy plane. And this requires, of course, that you get some picture of the paraboloid, okay? Now you could start a picture of the paraboloid. In the xz plane, you have z equals 9 minus x squared. Well, it should be very obvious that this is a down-facing parabola because of the negative x squared, and that its vertex is at 0, 9. Okay? And somebody's making a lot of gestures here, making me think I've done something really stupid. So let's see what have I done. Okay, there was some confusion about the xz plane, xy plane. Remember when we did quadric surfaces, we look at the xz, yz, and xy plane intercepts of the quadric surfaces. And then we even looked at z equals 1, z equals 2, z equals 3 intercepts. You might need to review some of that because you do need that three-dimensional understanding in order to deal with ripple interval. Okay? And so I'm breaking it down to just one plane. Okay? This is ultimately going to require a triple integral. And you've already been through double integral, so I'm going to do this one with a double integral, but then I'm going to show you how to do it with a triple integral. And we'll do this one with a triple integral. Okay? Okay, so in the xy plane, z equals 9 minus x squared. Is an inverted parabola congruent to just the y equals x squared parabola. It goes through the point 0, 9. In the yz plane, it's the same, except it's y instead of x. Because, okay, again, make sure we understand, it, in the xz plane, that's what we get when y is 0. If y is 0, we get z equals 9 minus x squared. That's the picture. In the yz plane, it's the same picture. This is a paraboloid of revolution, then. We revolve this parabola around the z-axis, and that's the region that we're looking at. Okay? Now we have to be able to describe that region ultimately in inequalities. Just to build up to it, we're going to take a quick look at the three-dimensional region. Okay, well, over here, this is a point 3, 0. This is a point negative 3, 0. Okay? And, you get the x-intercept by letting y equals 0, or in this case, z equals 0. 9 minus x squared equals 0. X equals plus or minus the square root of 9 plus or minus 3, right? It's basic pre-calculus. Okay, so down here, we can sketch this region. I'm going to just sketch a 3 by 3 square here, or 6 by 6, okay? In other words, we're going from x equals negative 3 to x equals 3. If we extend these lines, we're seeing we've got y equals 3 here and y equals negative 3 here. The reason I sketch those lines is the vertices of this paraboloid, if we confine it to the x equals 0 plane, in other words, I'm sorry, in the z equals 0 plane, plus y squared equals 9. Told you I'm not with it today. If z equals 0, you got 9 minus x squared minus y squared equals 0. So x squared minus y squared has to equal 9. Otherwise, when you subtract it from 9, it wouldn't be 0. Okay. Now, circle radius 3, the center is obviously the origin. So that's what I'm sketching down here. Circle of radius 3. And I'm using this square to draw a really bad representation of that circle. Okay? There it is. Now, above it, make z equals 9 a little higher. Okay, let's say that z equals 9 here. So this is the point 0, 0, 9. Our z-scale's a little squashed from our x and y scales, but we can deal with that. Okay? So we would have a parabola coming down here. And we'd have a parabola coming down here and another one coming down over here. And we'd have parabolas coming down actually to every point. So we'd have something that looks like this. And in any plane, if z equals 8, let's say, the plane would be 9 minus x squared minus y squared equals 8. So x squared plus y squared would be 1. We'd have a circle of radius 1 in the z equals 8 plane. Now, I'm not going to write that down, take notes, or go back and read the AI summary, or actually look at the video, whatever works for you, or go back and review it in your book until you can do this, okay? And maybe you can, maybe it just didn't occur to you would in the context of these problems. Look at the z equals 8 plane. Look at the z equals 7 plane. If z equals, look at the z equals 5 plane. If z equals 5, x squared plus y squared equals 2. So we come up to z equals 9 and we get a circle of radius, 8, I'm sorry, we get a circle of radius 1. Come up to z equals 5, which might be about here, and we get a circle of radius 2. Down here in the xy plane, we have a circle of radius 3. And now if we take the visible parts of this thing, which go kind of from here to here and around to here, and maybe we can see a little bit of this, then we ignore all the white stuff. The blue gives us a reasonable approximation of the picture, okay? If you don't have the picture, you're unlikely to figure out how to set up the integral because you won't have a picture to allow you to refer to when you try to set up the inequalities. Now, it should be very clear that this circle down here in the xy plane circle is defined by -3 less or equal to x less or equal to 3. It's one thing it's defined by, right? It's not y. Y doesn't go from -3 to 3. If we let y also go from -3 to 3, we get the whole blame square. We ask ourselves a question. Okay, in this circle, okay, well, to do this, you really want to draw the circle. And it's really kind of dumb to draw the axis before you draw the circle, at least in my case. Trying to fit a circle to a given point or a given line is much harder than just drawing a really good circle. Oh, chalk stuck there, it would have been perfect. Okay, and drawing a couple of axes. Okay, let's flatten that down a little bit. Still not a good circle, but it represents a circle. Okay, really, if I hadn't hit the wet spot down there, that's where it went haywire. You can even see it. Would have been perfect. You believe me? Yeah, I was saying that. You don't believe me. I don't believe me. Okay, so we have x coordinates from 0 to 3. We would partition the x axis from 0 to 3. So we think of partitioning the x axis from 0 to 3. I've written out all the symbols. You should be writing out all the symbols. You should be doing what you see me do. Failing that, at least do what the book tells you, which is the same thing I said. Okay? So you partition the x-axis, and then for each partition, you have a whole set of y values, but they don't go from -3 to 3 unless your partition just encompasses the y-axis, in which case it wouldn't be an interval partition because it's got 0 dimension. Okay? Y goes from here to here. Now, whatever x is, sample point is x equals xi star. Right there it is. Now, if you follow that sample point, where it hits the circle down here, where it hits the circle up here, well, what are the y coordinates? What's the y coordinate here? What's the y coordinate here? No, write it down for me. What's the y coordinate at each of these, either of these points? Because they're symmetric. If you know one, you know the other. See if you can figure out the y coordinate in about 30 seconds. Seen this picture. I just dropped a huge hint. I drew this triangle. Okay. There's a way to do it also with symbols, but most people are going to do much better if they have the picture. And remember that I've been telling you all along, I'd like to see more pictures in your homework. Y'all aren't doing very well with pictures. Okay. You might be doing well in your head with pictures, but I'm not seeing them. And the fact that I haven't seen this tells me you need to think much more in terms of pictures and soon, because everything is pictures now. If you're really good with symbols, you can probably get around it. But you also got to be good with symbols, and you are. But without the picture, I don't know that you're going to get everything you need to get. Okay. Well, drew this picture, and I saw some things. I saw XI star on some pictures, okay? And still didn't see labels on a lot of them, okay? You got XI star. The label on this one could be Y because that will be your Y coordinate. If your Y coordinate is what you're trying to find, then that is the length of this vertical side. What else do you know? Finally, somebody said radius. Well, and I said that's the hypotenuse hypotenuse. Okay? It's the hypotenuse of the triangle. It goes from the center to the edge of the circle. It's 9. So what's Y? Well, it should be immediate. It should be immediate because by now you should have done this several times. Okay? But if you're not looking at pictures, I'm not sure how you're getting the right answers. Okay? So I'll stop nagging you about pictures right now. I've nagged you enough. But there we have it. Okay? So the Y coordinate here is squared of 9 minus xi star. What's y down here? Well, by symmetry, you know it's going to be negative the square root of 9 minus xi star. The equation you use to solve this is and it should be xi star squared. Wrote the star and felt like I'd already written an exponent. I told you. A little distracted today. Okay. Y squared is 9 minus xi squared. What you get is y equals plus or minus the square root of 9 minus xi star squared. So right there's where the minus is, right? Right there on the picture that you should be drawing. Okay? Also, just advice. It's more or less important for you to focus on what you're doing by writing down everything you see on the board. You're not going to be in lectures in the next couple of years where you're going to be able to write out everything on the board. It's going to go too fast. Okay? And I actually go a little too fast. So when I say something like, draw this picture, slop something down that looks sort of like a circle with an X and a Y axis crossing it sort of the center, just enough that you can get it. Don't take a lot of time to draw these pictures. I know you want to be meticulous, and that's a good quality when you have enough time to be meticulous, to be able to slop something down and still get content out of it. Okay? And then later on, draw a nice meticulous picture if you think it'll benefit you. Okay? So it doesn't take long to draw a circle and an increment and a bunch of lines here. But most of you took too long to do that. Okay? It holds up progress if you take too much time on it, because it holds you up from thinking through what you got to think through. Okay? All right. Okay, so we can describe this circle. Well, first of all, x goes from -3 to 3. Now, if you know what x is, what are the limits on y? Given the value of x, because we've already said x is every value between -3 and 3, that'll span the entire circle, right? But if you're given x, y is between 9 minus x squared at the top and negative square root of 9 minus x squared at the bottom. Make it very explicit. Again, I've drawn a bunch of these partitions, but so we partition x from -3 to 3, and it looks like this. So now we've got a bunch of x partitions. We take a typical partition, any old partition, we just call it the ith partition. That's a pretty common convention, very common. And now we partition same for given x sub I, which is a sample point in the ith interval. we partition all the y values from here to here, wherever that partition hits the circle, wherever that xi value, the line where xi is constant, hits the circle, we partition it. And the partition is going to go not from -3 to 3. It goes from negative square root of 9 minus xi star squared to 9 minus square root of x to the square root of 9 minus xi star squared. Okay? That's what we're talking about. That's how you think through the limits of the integral. Now, your typical increment and all that, and go back and see what I've said. What we have then is -3 less or equal to x less or equal to 3 negative square root of 9 minus x squared less or equal to y less or equal to square root of 9 minus x squared. And what happens to z? Where does z go if we try to partition this? It goes to 9 if x hat and y both happen to be 0, but if x and y are something, either one is different than 0, it's not going all the way up to 9. You try to go up to 9 from here, you're going to bump your head pretty hard. Okay? If you're doing it by vertical leap, if you've got a 9-meter vertical leap and you just barely get to the top here, you're going to bump your head right here, but not too hard. If you're over here, you're going to fracture your neck. Okay? You're going to hit the surface. Yep. NCAA basketball tournament, I must be thinking vertical leaps. Okay? I haven't been paying any attention. I just noticed they got to the Sweet 16 or Tennessee had beaten Virginia. I just saw a headline. I don't pay any attention till they get to the Final Four. Just look at it from a distance, and I'm way too busy to even look at it. I just happened to see that headline. Okay, I'd love to watch the games, but nah. Okay. So anyhow, in terms of vertical leaps, if you leap from anywhere but the center with a 9-foot vertical leap, you're going to hurt yourself, right? Or at least you're going to bump the top. So how far are you going to go if you're point X, Y? How high is the surface above the XY plane if you're standing at the point XY in the XY plane? Okay, now we just have way too much discussion, except that that's what we needed. Okay, way too much discussion about how high that was above our heads if we're at the point XY. Okay, if we are at the point XY, then since this paraboloid is defined by z equals 9 minus x squared minus y squared, the height is 9 minus x squared minus y squared. Okay? We go from 0 up to our limiting value of z. Just like if we're on this circle, if we're at a certain x coordinate and then we want to move in the y direction, we encounter the circle when we've moved square root of 9 minus y squared units. Okay? You really need to understand that. And I'm not sure, you know, one thing that really irritates me about your text and about pretty much every text that's being published these days is they don't make you think about what the shape of the thing is. They just show you a graph of the completing thing. Okay? Too many graphs. They're showing you too many graphs, asking you to think through too few graphs. And then again, as I keep saying, I'm not seeing enough pictures to make me confident that I've not been seeing enough pictures to make me confident that you're going to be ready to do this. So try to beat you over the head so you get ready. All right. So Z, we're talking Paraboloid above the XY plane. If you have X and Y, this means this paraboloid has its boundary at Z equals 9 minus whatever X is squared minus whatever 9Y squared is. The floor is at 0 because it's above the XY plane. Now that we have that, we could write a triple integral. Or having just this, we could write a double integral. And since some of you were mixing up what goes into the triple integral with what goes into the double integral, I'm going to do it both ways. Okay. Let's see if I've got, I don't know if I've got any blank board down here. But I can do this. So I get here. Okay. Uh, okay, I think I've got this much room. Okay. We could integrate the altitude, the changing altitude, which is only 9 at one point, and which is 0 at an infinite number of points. Okay. And with everything else in between at an infinite number of points on a circle, which is cut by Z equals a constant, which constitutes a contour line, if you want to draw it that way. You need to reconcile all those pictures and all those ideas. Okay. So you got x squared plus y squared equals 3 circle. Well, region is -3 less or equal to x less or equal to 3, negative square root of 9 minus x squared, less or equal to y, less or equal to square root of 9 minus x squared. The integral is the integral from y equals square root of negative square root of 9 minus x squared to the square root of 9 minus x squared with respect to y, and then integrate that with respect to x from -3 to 3. Oops. Now I'm mixing up what you do with a triple integral with what you do with a double integral. Thinking about two things at once. What's any of this have to do with basketball? Okay. You've got to integrate nine minus x squared minus y squared. The function you're integrating is just the altitude. Now, if you want to do a triple integral, and I'm sure that's what you really want to do. Oh, it's getting dangerous here. I think I gotta do this. integrate dv over the volume. Okay, that integral is going to go from -3 to 3 because of this. Right here is exactly what you need to write out the limits on this integral. X goes from -3 to 3. So we'll say, okay, -3 to 3 is going to be with respect to X. And then y from negative square root of 9 minus x squared to the square root of 9 minus x squared. That's for y. And then for z, 0, and 9 minus x squared minus y squared. Right there it is. If you have the inequalities, you write down the integral, boom. Okay? Now that's the kind of stuff you got to do section with 5.5, 5.4. Anyhow, first section on triple integration. Okay? You have to think it through that way and in detail. Many of the problems that I assign involve paraboloids. Sometimes there's a paraboloid above and a paraboloid below. Sometimes it's a cylinder. Or sometimes it's a parabola within a cylinder. Cut a parabola out of a cylinder, and what have you got left? Okay? But these things are all easy to describe. There aren't a whole lot of ellipses. Because ellipses, the integrals get tricky. Concept isn't tricky, but if you can do it with circles, you can do it with ellipses. But the integration is a lot more difficult. Okay? Now, there are two more things I want to do. And I urge you to pay attention to you're paying attention now. I mean, everybody's got good attention. That only takes you so far. You got to follow up on it. Never mind. I don't need to do mass density. I need to answer the second question. Now, the average value, but we have a function f of x, y, z equals x plus y. I could put a z in there if I wanted to, but I'm just going to do x and y. Okay? And it could be a lot more complicated function. Be the arctangent of x times the cosecant of y, whatever. Something you probably wouldn't be able to integrate. It might be impossible to integrate in closed form. Okay, what's the average value of this? Over the region? First place, you have to integrate f of x, y, z over the region. Now your picture is you got your region. Looks something like this. Down here, you've got an area increment in your XY plane. Well, let's not even do that. Let's just take a typical volume increment somewhere within this solid. It's delta V I J K. You partition the circle down here, and you got an XI and a YJ. You then partition the rectangular column above that increment all the way up to 9 minus XI squared minus YJ squared. And you've got a bunch of little rectangles, and the typical one is V sub IJK. Okay, you partition the X interval using subscript I, the Y interval with subscript J, the Z interval with subscript K. So you have delta V IJK. Into the integral of f of x, y, z over the region. This interval contributes f of x sub I, y sub j, z sub k, delta v, ijk. Incidentally, in the AI summary from last time, I find that ChatGPT does not want to put IJK subscripts on your volume increment. Okay? I think I made a note in there. And I'll convince ChatGPT that they really should do that, since ChatGPT tries to be non-confrontational. It'll probably go ahead and do it, even though it thinks I'm an idiot for putting it on there. Okay? Just warning you, I'm going to use IJK here because I think it belongs there. We're talking about one specific integral, and we're putting the IJK on the X, Y, and Z coordinates of the sample point with an asterisk. And ChatGPT does that, but then it doesn't want to do the IJK on the volume increment. Talking about the IJK increment. That's really what I'm trying to emphasize. One single increment contributes this. If this is density, then it's the density at your sample point multiplied by your volume, which gives you mass. Okay? If it's heat content per unit of volume, it gives you the amount of heat in that volume. Okay, among other things. Okay, so because of this, without going to all the formalities, right there's your integral. It's over this region, and this region's already been described in inequalities. So it has the same limits that this one does. This is a volume integral, the volume integral. -3 to 3, negative, I figured out the square root on that 9 minus x squared there. Negative square root of 9 minus x squared, the square root of 9 minus x squared, and from 0 to the square root of 9 minus x squared minus y squared. Because this sum, triple sum, you sum up this integral over all i's, all j's, and all k's, you take the limit as the size of the regions goes to zero, and you get the integral that you can do using the integration techniques that you know. Okay? Hopefully. A lot of integrals, there's no integration technique that will work. And a lot more integrals you feel like there's not any because you just can't think of it. I mean, yeah, new tricks for solving integrals being discovered periodically. Okay, well, anyhow, it's that. It's the integral of f of x, y, z, dz, dy, dx, but that's not the average value. That's the total amount of stuff in there, right? The average value, you got to divide by the volume. And that's the triple integral that I wrote up here. -3 to 3, negative square root of 9 minus x squared to the square root of 9 minus x squared, 0 to the square root of 9 minus x squared minus y squared of dz, dy, dx of your volume increment. Okay? This is just the integral of your volume increment, which is going to give you the total volume if you got the limits on the integrals right. This is the same integral. You can't read it down here, but it's a volume integral. So you got the integral of your function f divided by the volume of the region. Which is the average value of f on the region. Just like the average value of an integral of function one variable, you divide the integral by the length of the interval. In two variables, you divide the integral by the area of the region. For volume integral, you divide the integral of the function divided by the volume of the region. So if you've got 100 kilograms, listen to this now, 100 kilograms in a section of a paraboloid with an area of 20 square feet, what's that tell you? 100 kilograms in a 20, I said square feet, 100 kilograms in a 20 cubic foot region, okay? Tells you got 5 kilograms per cubic foot. That's what it tells you. But that's an average. It doesn't tell you how that mass is distributed within that paraboloid. It might get denser toward the bottom. Yeah, maybe you have poured some stuff into it and the pressure is compressing the stuff down toward the bottom. So where it's denser than the stuff toward the top. Okay? And maybe there's some other thing that's going on. And if you got heat content of a material in a paraboloid, that can vary just about any way, okay, depending on how it's been heated. Okay. Well, try to take a lesson. You have to be systematic setting these things up. You're going to have to spend some serious time. You're going to have to do a little bit of review. Okay, make sure you understand what's going on. I'm now going to do the same thing in cylindrical coordinates. Okay, because I've assigned problems in 5-6, maybe it is, or 5-5. Some of the problems involve cylindrical coordinates, some involve spherical coordinates. I put the spherical coordinates off till next week. Okay. If I possibly could, I'd put the cylindrical coordinates off, but that would leave us so much stuff in the time we have left that everybody die. Okay, I want some of you to survive, preferably all of you. Now, same region in cylindrical coordinates. Yeah, I don't know if you've had time to get to the assignment that was officially due today on cylindrical coordinates. Okay? Yeah, the spherical and cylindrical coordinates, section 2.7. You want to be sort of familiar with them, but we've been talking about them. So the same region, region between z equals 0 and z equals 9 minus r squared. The r coordinate is just your distance from the z-axis. In the RZ plane, you got z equals 9 minus r squared. Zero less or equal to theta less or equal to 2 pi tells you that you get to revolve this thing about the z-axis. So you get the same picture you had before. Badly drawn, but there it is. For a given r, you know how high this thing is. Before I said, if you're at xy, how high do you have to go to touch the paraboloid above you, right? Really, the only thing that mattered about x and y was how far you were from the origin, okay? Because the paraboloid's symmetric about the z-axis. This takes advantage of the symmetry and makes the integral much simpler. Since theta goes from 0 to 2 pi, you have this picture where your r vector, if you wish, makes every possible angle with the polar axis, say with the x-axis. So the region is zero less than or equal to r less than or equal to 3. Okay. You don't have to go to a negative r because you're going to let theta go all the way from 0 to 2 pi. So it's like you've got just this part of the parabola, but now you get to take this thing and rotate it 360 degrees. Okay? You don't have to rotate both sides for 360 degrees. We could go from r equals -3 to 3. We get the paraboloid twice. Well, we're just, this is what we're doing. 0 less than or equal to r less than or equal to 3. 0 less than or equal to theta less than or equal to 2 pi. And 0 less than or equal to z less than or equal to 9 minus r squared. That's a much simpler region than the one we had before. Because the only variable we see in the limits is r. All the other limits are fixed. And your book would call this a polar rectangle. Okay. It's a polar rectangle, which we see in our usual perception three-dimensional space, as a circle. You've seen that in your book, I hope. That's what we're talking about. It's easy to integrate over. The area of this thing, well, we'll see. Okay. So we get the integral from 0 to 9 minus r squared. That's with respect to z. And then from 0 to 2 pi with respect to theta. And from 0 to 3 with respect to r. Now, the only problem is this isn't a volume increment. To get the volume increment, as we talked about fairly extensively, both with polar coordinates and the other day, it's r dr d theta dz. Okay. Now, since r is the last integral we want to do, because we got r as the limit in one of our inner integrals, we write it this way, that nobody watching be able to see. Okay. That's a really easy integral. Okay. I can do that in just a second. I didn't want to take the time to do the other one. Besides, I want you to. No, I'm not actually going to do it because we're really missing time here. But you substitute this in, you're going to get 9 minus r squared quantity squared. So you're going to have r's, or you're going to have r to the fourth, you're going to have r, and you're going to have numbers. Simple polynomial. Going to be easy to integrate when you get out here to dr. Okay? I'm kind of skipping a step here. I said that wrong. You're going to have 6 power of r as well because you got to cube this. No, you don't, because it's r squared over 3. It's squared. Ignore me. Okay. Anyhow, that'll be over 4. Integrating theta from 0 to 2 pi. 2 pi d theta is just going to give you 2 pi. And that's going to be dr. And that's going to give you the total volume. If you wanted to then evaluate, well, you want to find the average value where your density is given by x plus y, you would have to change x plus y the polar coordinates. Okay. So I'll just make a note. The density f of x, y, z equals x plus y becomes f of r beta z equals r cosine theta plus r sine theta. And I will note, I haven't graded your tests yet, but I've read through them. And one thing that stood out to me in several papers was people were not able to do simple conversions correctly. Converting from rectangular to polar, polar to rectangular, okay? Stuff like, you absolutely have to be able to do that. You simply need to review that, make sure you know. Some people did, but more people didn't than did. I saw some strange results there. I'll try to post some notes on what I'm seeing on the final. For various reasons, my time right now and for the next few days is going to be pretty limited. Okay. So I'm going to do the best I can there. Might be a couple more days before I get the test graded. Okay. Okay, well, that's it. Here, read the text if you need to. Get AI to teach you how to do it, but not to do your problems for you. I know you know better than that. You have all kinds of options, all kinds of online resources. You have the videos, you have an AI synopsis of the videos for this class, which incidentally have links that don't always work, but I've about fixed that for most courses. I'm not sure I've done it for yours. The software I'm using, the editing software, keeps changing my links so that they're links internal to the system, files rather than URLs. So it's a fairly easy copy and paste. It takes a while, but not too long. It has to be done really carefully or I screw the whole thing up. So far it's going okay. I'm really looking for one of the things and don't find it, let me know right away. Because if I know, then I can identify the problem and it's not that hard to fix. Okay? Aggravating as heck because there are more hoops I have to jump through to post these things. Because the thing is messing with them. But it's what I've got. Okay? And it's like I say, it's just distraction, it's a pain in the neck, but it's not that bad. So let me know. I can fix it.